Hello everybody, my name is Fatima Albsher. I'm a researcher and innovator interested in robotics, and today I'll be talking about my project. Every year, millions of hectares of lands are lost due to degradation. Replanting these trees is difficult and hard, and that's because manual planting is slow, expensive, and almost difficult in regions like Saudi Arabia where it's extremely hot. That's why I developed my project, an autonomous rocker suspension robot for land degradation planting. The solution is an autonomous robot designed specifically for degraded and deserted areas. It uses three key ideas. First, a four-wheel rocker suspension system that's going to help the robot move stably on uneven surfaces. Second, a GPS-independent localization system that's going to help the robot navigate accurately without using satellites. And lastly, a multi-purpose extension system that's going to help the robot do multiple tasks, for example, seed planting and soil monitoring. Okay. Now let's talk about the robot design. This is our 3D robot design, and this is just the first version. Now let's talk about it on the actual prototype. We used the four-wheel rocker suspension system because after doing a lot of research, we found out that even in Mars robots, it's been used and it's the best for uneven surfaces. So how does the system work? We have two rocker suspension systems connected with a differential bar. And the system helps the wheel stay on the ground even if an obstacle is ahead. That's why we chose it. We have a control panel that contains a start button, an on and off switch, an emergency stop button, and a LED light so that we can tell if the robot is on or off. So this is the second version of our robot. Of course, it has a rocker and 3D printed rocker suspension system that's going to make it more accurate. And of course, we're working on the localization and multi-purpose module extension system. Now we're going to talk more in depth about the localization. So in the localization, we have 4 transmitters and a receiver on the robot. The transmitters are going to send data to the receiver that's going to make a grid pattern seen in the photo that's going to help the robot move by the grid. So why did we choose the system? We chose the system because, first of all, it's local, and second of all, it's low cost, instead of using GPS, which is very high cost. One of the main problems in localization in big areas is that it's very hard. So even if a robot wants to do localization in very large scale areas, it needs to use high cost systems, for example, like LiDAR and other stuff. But our system uses a low-cost system that's going to help do localization in large areas without any problems. And so for our multi-purpose module extension system, we're working on it. But why did we use this system? Is that because we want it to be a universal robot so that farmers can use it for more than one thing. For example, seed planting and soil monitoring. That's why we use the system. And so this is our code, as you can see. Now, this is our control station. Of course, our robot is autonomous, but we like to monitor our robot, so that's why we have this control station. It shows us the voltage of the battery, and also it shows us the status. As you can see, it is autonomous right now, but in case of emergencies, we can change the status into teleop, which is going to help us move the robot. Of course, we have our robot IP, and also the robot status, CAN, RAM, and other stuff. So now we're going to do a robot demonstration. Of course, I'm going to open the code from the control station, and let's talk about the robot. This is going to be the front of the robot where the multi-purpose module system is going to be placed, and of course we have our differential bar. Now I'm going to start the code. Of course, as you can see, even while obstacles ahead, the differential bar and the rocker suspension system helps the robot move above obstacles. Looking ahead, I'm working on an AI-driven analysis for soil health and developing a swarm system to make a bunch of robots work together. My name is Fatima Albsher, and I believe that we can build a greener future one robot at a time. Thank you.